Okay, trigonometry mixed problems using sine and cosine rules with a non-right angle triangle. So I've got some formula there for you to revise before we can do the examples. So that's the last bit. All right, well, let's start the example. I've just highlighted all the keywords here. So the example 1, part A, the angle of elevation of a tower from point A is 72 degrees, from point B 50 meters further away from the tower than A. The angle of elevation is 47 degrees. Part 1, find the exact length of AT, the distance from A to the top of the tower. Part 2, hence or otherwise find the height h of the tower to one decimal place. So our angle of elevation, as I told you before, it is we're using the base sketch will be the right angle triangle, and the angle of elevation is right there. Okay, so right angle triangle, and there's 2 points. So obviously you're going to have two elevations, and point A and B is about 50 meters further away from each other. So I've sort of sketched it as what I was thinking there. So I started with a right angle triangle, obviously, and then I made it 2 triangles overlapping, sort of, because the B is further away from the building, the tower, okay, and then between A and B is 50 meters apart, okay, and then part A was to find the exact length of AT, which is AT here, so I'm just making AT as X, and now I just label the AB and then T and C, so I can use that, well, naming it will be easier. So here is my diagram, the neater, better, prettier version of it. Okay, so I've done that, and then you need to think about which triangle you need to use to X, because this AT is a common part of this triangle and this triangle. So you need to think about which one I need to use. Well, this one I can't really use. That's okay, but then I've got 2 unknown side. I can't, it's a bit useless. So I'm going to choose triangle ATB, which is this side, and I already matched up with angle and the side. So here it is. Let's have a look. So I just resketch that, and this angle I can find from here, because that's what is it, 180 take away 72, which is 187 to 108. Okay, so that's my angle, and this one is easy because it's angle sum of triangle, so I'm going to go 180 take away 47 take away 108 will give me 25. Okay, so I've got all the angles I need and the length. So TAB, angle TAB will be 180 take away 72, 108, and then angle ATB will be 180 take away 47 take away 108, which will give me 25 degrees, because angle sum of a triangle. Okay, and then finally I can use sine rule. So always unknown angle or side first. So I'm going to put X, and that's opposite. I've already matched up. Sine 47 equals 50 sine 25, that was 25, and I'm timesing by sine 47 on both sides. Left with x because I want to make x the subject, and then its exact length. So I haven't done anything. I didn't put that into the decimal. So part 2 was the finding a h. So I'm just going to put this diagram there, right there. So h will be this, you know. So obviously I'm going to use the triangle. What's that? ACT. So I'll just sketch that there. And we know what x is from previous question. So I just put exact length there. And then I have to find a h. So matching, and then matching. No, I don't think so. I don't need to do matching, isn't it? Because it's a right angle triangle. Yep, you need to be careful because you keep matching things, you think everything has to match, but it's not, because it's a right angle triangle. Wonderful. So we don't have to do it, we just have to do SOHCAHTOA. Already written there, I forgot about it. Okay, so that's my opposite, that's my hypotenuse. O and H is sine. So I'm going to do sine 72 equals O over H over the exact length. Now that means H equals times this 2, yeah? And then if you put that in your calculator, you will get 82.3 to the correct 1 decimal place. That wasn't too bad. Part B. Now, I have to tell you this. It's going to be a little bit longer video. So if you need to pause it and have a break, please do so. Okay. A ship sails from Sydney for 200 kilometers on a bearing of 40 degrees, then sails on a bearing of 157 degrees for 345 kilometers. And they says how far from Sydney, and I'm just going to turn this one over because I can see the other diagram, and to the nearest kilometers. And the part 2, what is the bearing of the ship from Sydney to the nearest degree? Okay, again I'm going to highlight this, and what is it? From Sydney, that's my starting point for my bearing question. And 40 degrees and 157 and 340 kilometers, 200 kilometers, and then how far, that's a distance, and the next one is what is bearing. Okay, from Sydney. So I've done that, and first step is always the diagram. Okay, so I'm just going to show you the diagram I've done. So all the information says, so sketch the compass there, bearing, and the first one was a Sydney, everything was from Sydney, so that's my starting point. And then it was for 200 kilometers on bearing of 40 degrees, so that's 40 degrees and 200 kilometers. And then it says here, that's the key, it's saying that there's another compass bearings happening here. So 2 bearings were happening. So next one was 157 degrees from true north, and the distance for first was 200 kilometers, second one is 345 kilometers, and we join them together because it says how far from Sydney to where the boat is. So that's x. I'm just going to put x as the distance. So you need to think about this. So we need to plan. So let's have a look at this. Can I use sine rule or cosine rule? So I sketch this again here, so it's just clearer and easier for us to calculate. So I don't think we can use sine rule here because I can't really match up with any angles. I can't see any angles there. But if I can find the angle P, I can use cosine rule for this one, because remember cosine rules, you need to have all this side covering, almost like protecting the angle, and then we can do that. I might just cover this one up. Yep. Okay, so find the P. How are we going to find the P? It'll be, I have to go up a bit here. I'll just name the P here and Q here. So P will be, now can you see that's alternate angles because there's two parallel lines. That's 40, that's 40, isn't it? Yep, so that's good. And here is what? 180 take away 157. Yeah, so what's that going to be? It's 23. So what's a P going to be? It'll be 40 plus 23 will be 63. Voila, there you go. So we got 63 right there. So now we have to use, I'm going to use the quicker version of the finding an x using cosine rule. So it'll be 200 square plus 345 square minus 2 times that, and the cos 63, where it's the opposite to the side. And then if you put that all that in your calculator, to the nearest kilometers will be 310. That's just finding the part 1, how far, the distance. Now part 2, we have to find the bearings. So that'll be this part. This is the bearing, isn't it? That's what we have to find, the bearing. Okay, so that means 40 degrees, the theta part will be the out bearing. Okay, so again, we need to have a bit of a plan. So we need to think about, if I could just match up with this and this, that'd be fantastic. So I can find the theta, okay? Because we need to find the theta to find the whole bearing. So let's do that. Sine theta over 345 equals sine 63 over 310. Calculation, just remember it's angle, so you've got to do shift sine. But that's not the bearing, is it? That's just part of bearing. So whole bearing will be 40 plus theta, which is 82 degrees and 34 minutes. And if we do that, what do we get? 122.34, and to the nearest degree 123, because it's more than half. Okay, so that's what we've done. Excellent. Part example 2 now. A motorbike and a car leave a service station at the same time. The motorbike travels on a bearing of 80 degrees. Okay, so I'm going to just, as I read, just highlight it. And the car is a 15.7 kilometers and bearing of 108 until, now this is going to be a little bit tricky, until the bearing of the motorbike from the car is 310. So key word is from the car. It's not from this service station, it's from the car. And how far, correct to 1 decimal place, has the motorbike traveled? Now I think here keyword is from service station. Okay, from service station, so we need to think about that. Okay, of course, most important thing before we start anything else, step 1 is the diagram. So this is the diagram already prepared for you. It's like a cooking show, isn't it? So diagram is here, and north, and then that's a service station, and both of them started together So the M for motorbike and the C for car. So bearing was 80 degrees for motorbike, and the but we 108, yes. So the car was 108, so they're separated, and the distance was only given for the car. And this is the part you have to be very careful. Now from the car, so your starting point has changed now. It's not station anymore, it's the car. And it's 310 motorbike. Where the motorbike is the 310. Okay, I just put the 50 degrees so that you know it's a 360. That little part is 50 degrees. So as long as you could actually sketch that, that is very good. And I'm just gonna continue with this. So I sketched a little bit further and put all the information I want to use. So that was a 50 degrees. Now, to find this distance, how far, so how far is the motorbike travelled from the station? So that's this what this is. And I'm sort of trying to match up, remember? Trying to use a sine rule if you could. If you can't, obviously you use a sine, cosine rule, but if it's a sine, so I'm just trying to match up, and it does work if I can find this angle. And I think I can work around it because there's a lot of bearings here, so I can sort of work it out. So that's 50, and if that's like alternate, isn't it? Alternate. So how do I get this angle? It's 108 take away 90, isn't it? Because 108 take away 90, I will get 18 degrees. Okay, so that for that little part is 18 degrees. Now whole thing is 90, so if I can get 90 take away 50 take away 18, right, I will get this angle. So this angle was 90 take away 18 take away 50, it will be 22 degrees. Yeah, right there. So I'm going to put 22 here. And what was this one? This one is easy actually. It's what? 108 degrees take away 80 degrees, which is 28. Okay? And the angle sum of triangle, I can find this one. 180 take away 28 take away 22, I will get 130. So that's 130. Okay, I think I've got everything I need. So to find x, I will go using sine rule. So I'll go x over sine 22, and then 15.7 over sine 130, and I times by sine 22 degrees on both sides, and I will make x the subject, 7.7 kilometers, 1 decimal point. Okay, excellent. Now, did I tell you this is going to be long one? So just pause it, have a break, come back. Okay, so next one. Submarine is being followed by two ships, A and B, and 3.8 kilometers apart, with A due east of B. Okay, so that's something you have to be careful about. If A is on a bearing of 165, so again, I'm going to put that one in there. And then B is a 205. I'm going to put that one apart. Find the distance from the submarine to both ships, A and B. So find that. Okay, so diagram. It's not too bad. Just think about the diagram. So here it is. I've got it already. So the A was on a bearing of 165. It's in the, that's what, 0 degrees, 90, 180 to 70. So that's where it is. And the second one is what? Bearing of 205, right there. And do you remember this? This is A is due east of B. So east of B. So A is east of B. So that's, if I had to draw another bearing here, starting with B, it's due east. So A is, so what that really means is this line and that is perpendicular. I mean parallel. Okay, parallel to each other. So that's straight line there. Okay, that's what it means by A due east of B. So we got the distance between A and B is 3.8. I've got everything I need. I just labeled this line and that as X and Y. So I can see the distance from submarine to each boats there, A and B. Okay, so to find, I just cover this one, so I'll do one at a time. So X, to find X, I need to find this angle and then matching up with X and this angle and that. So let's find the angle here. So how are we going to find this? This will be same as this, won't it? So what's this going to be? It'll be 165 take away 90. Yeah, 165 take away 90, which is 75. This will be 75. And then I'm going to find this angle by using this one. That will be same, right? So how do I find that one? 270 take away 205 will give me 65. So that's 65, 65. Okay. And this one, that's not bad. 180 take away 65 take away 75 will give me 40, isn't it? Yep. So got that. Now I can do sine rule. So X over sine 75 and 3.8 over sine 40, and I will get 5.7 kilometers from B because X is from B. Yeah, and then the Y part, same, exactly same, but you make sure you mention from A. Okay, so that's not too bad. So example 4. A plane leaves Adelaide and flies for 875 kilometers on a bearing of 56 degrees. It then turns, so that's just indicating of second bearing there. So turns and flies on a bearing of theta for 630 kilometers until it is due east of Adelaide. So it's on the Adelaide side, east, somewhere right there. Okay, and evaluate, find theta to the nearest degree. Okay, so if I sort of highlight all these, okay, so diagram is important, as I told you before many times. So first thing you have to think about is the diagram. So let's have a look at this. So what happens here right now is so 56 degrees Adelaide, so that's my Adelaide, the starting point. So plane leaves there, and it was at first 56 bearing and 875 kilometers, and then it turned, right? Turns and then flies away. So we don't know what the bearing was, but it's going and it stops right there due east of Adelaide, because that's Adelaide and that's east. So it stops right there. Okay, so that's what it means. Now we have to calculate the bearing. Okay, So if I could find, so this is my plane, if I could find this little angle here, x, what I call it x, I can find bearing by taking that x away from 180. Yeah. So how am I going to do that? How am I going to find x? Now, I can't really use any of sine rules and cosine on this side yet. I need to work on this first. So if I can find the h first, and then if I can find h, I can use cos on this one to find the x. Yeah. So how am I going to find the h? I'm going to use this triangle. Not bad, because if I can find this angle, I can use SOHCAHTOA. So that will be 90 take away 56, which is 34 degrees. So I'm looking at this triangle right now. So first thing, I want to find h. Okay, I'm going to cover this. So sine 34 will be SOHCAHTOA all over h. So h over 875, h will be 489.29. And then I'll go on the other side, this triangle right there, and I found h, and I've got x there, 630, and I can use cos, isn't it? So that's cos. And then h over 630. Remember, angle, we have to use inverse trig ratio. This time it's cos. You use a shift cos, you'll get that. But that's just x, isn't it? It's not a bearing yet, so be careful. Bearing was a theta, which is 180, take away that little angle, x. And when you do that, you will get 141 to the nearest degree. Okay? Well done, people.